Skibbity Sigmas, I am back. So, on to Unit 4. Let's see. If I do sodium chloride nickel, so we are finding the cation or the anion. I saw this one Instagram reel about helping memorizing whether or not cation or anion is positive or negative. So always think cations are positive. So cations are positive. Positive. Ha, get it? Ha ha ha. Okay. So, according to our periodic table, so chlorine has an anion of -1, and sodium has a cation of +1. So the +1, -1. So let's do a much harder one. So, well, not much harder, but like more difficult than this one. So MgCl2. Oh, there's a 2 in there. Oh my gosh. So Mg, as you can see, that has a cation of 2. So +2. And since Cl, as from the last one, has -1. So since there are 2, that would mean there are 2 anions. I bet. So the cation and the an always have to equal. I bet. Let's do InO3. Okay. Indium oxide. So, oxide. So the oxygen has an anion of -2. Since there's 3 of them, that's wait. They don't love me like I love you. I'm back. So, it's actually IN2. So, since there are 3, so -2 times 3 is 6. So the anion is therefore 6. And since this is that would be 6. Yeah. So basically the cation will always be a positive version of anion. Correct. I bet. Alright, so when naming covalent compounds, so like these ones, you need to do prefixes for covalent compound. Covalent compound. Prefixes. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Obviously 1 is mono, 2 is di, 3 is tri, 4 is tetra, 5 is penta, hexa, hecta, oct, non, and deca. So example, sulfur dioxide, that is SO2. How about diphosphorus pentoxide, that is P2O5. Pretty sure you can get the hang of that. Let's see. Okay, so for binary ionic compounds, for example, Na2O, that is sodium oxide, because right here, when it's binary ionic compound, the second name always ends with IDE. That is basically it for ionic compounds. So for transition metals, so like the middle ones, let's start with the cobalt, iodine 3. So how you would do transition metals, you would do cobalt, then parentheses, and then iodine, and then we would look at iodine. That is a charge of -1. Then since there's 3, there's 3 cobalt. So to get equal charge, let's do a harder one. Mg3N2 mag nitride. So since this one has a charge of -3, -3 times 2 is -6. Magnesium has 3, so it would have 2. The thing is 2. to even out.